Okay, your last one for this one. I ask you to find where the function is increasing and decreasing. For this particular one, to save you some time, I gave you the function and I also gave you the derivative. So that part has been done for you, so that'll save you a little bit of time. Okay, using our note sheet, using our steps, the first thing that we have to do for this particular one is look at our function, our original function, right beside it. You have to find the domain. So the way that you find the domain in a fraction is you exclude the numbers that make the denominator 0. So your denominator is x plus 1 squared. To solve that out, I can take the square root of both sides, and that gets rid of the square. I can move the 1 over, and I get a -1, and -1 is bad, so I have to exclude it. So it tells you to put this on the number line. So my number line goes from -infinity to infinity, and at -1 it has an exclusion. So that's what it looks like. So that is step 1, find the domain. Step 2. Step 2 says find the derivative. Done. They already did step 2 for us. After you find the derivative, you have to see where the derivative equals 0, and you have to see where the derivative is undefined. The derivative equals 0 where the top equals 0, and the derivative is undefined where the bottom equals 0. So the top number is -x plus 1. I'll set that to 0. The bottom part is x plus 1 cubed equals 0, so I'll set that to 0. To solve this first one, I'll move the 1 over, divide both sides by -1, and x would equal 1. To do this second one, I'll take the cubed root of both sides, so x plus 1 equals 0, so x would equal a -1. Well, -1 is already on my number line, but 1 is not, so I'm going to go ahead and put 1 on the number line. Now that's how it would look. So I have 3 intervals. Now you'll say, why is the -1 red? Remember at the beginning we had to throw that out. It is not in my domain, so you had to put it on your number line. Okay, let's pick some test points. Over here I'm going to pick the number -2. Over here I'm going to pick 0, and here I'm going to pick 2. Remember, you are plugging into the function, plug into the derivative. And the derivative is -x plus 1, be careful with that negative, and x plus 1 cubed. Okay, so I'm going to plug -2 in first. Okay, so it's the negative of x plus 1 over x plus 1 cubed. I'm plugging in -2. Okay, the negative of -2 would be a +2 plus 1, and on the bottom I get -1 cubed, which is a -1 answer. So if you simplify that, you get 3 over -1, which is a negative result. Okay, next let's plug in 0. It'll be a little easier. -0 plus 1, 0 plus 1 cubed. So on the top you get 1, on the bottom you get 1. That is positive. 2. When you plug in 2, -2 plus 1, 2 plus 1 cubed. So on the top you get -1, and on the bottom you get 3 cubed, which is 27. So you get -1 over 27, which is a negative result. Now, let's see what we have. I'm decreasing here, I'm increasing here, I'm decreasing here. Okay, so let's write that up. I am decreasing from -infinity to -1, and I'm also decreasing from 1 to infinity. I am increasing from -1 to 1. Now, here's a little trick. Normally, to find my local max and mins, I connect the arrows. But if I look right here, -1 is not in my domain. So even though it goes negative to positive, there's not a point at -1. It's not on the graph. So this will not be a max. Well, it would not be a max anyway. This would not be a min. And the reason it's not a min is that it's not even a point on the graph to begin with. It's thrown out. So you do not have a min here. But looking at this one, it goes up and then down. So you do have a max at 1. There is no min. Now, I know that's a little confusing, so let's look into something for a second. Let's pretend for a second that that was a min. That -1 was a min, which it's not. Remember the second part to finding these maxes and mins is to plug in to find the y value. To find y, plug into the original. So my original function is x over x plus 1 squared. Okay, so I ask you for this one to find f of 1. Okay, so here's where I am right here, plugging in this 1. So I get 1 over 1 plus 1 squared. So that's 1 over 2 squared, which is 1 over 4. Okay, so I have a relative max at 1/4. Well, let's say that -1, it's still kind of bothering you. You think it should be a min. Here's why it can't be a min. Let's pretend it was. Let's pretend we wrote it in the blank for just a second. Plug -1 to find y, plug into the original. If you plug -1 into the original, you get -1 over 0. Well, -1 over 0 is undefined. So you can't have a point there because it's not in the domain. And that's why there is no local min here.